Mais ça te permet en fait de faire un environnement.
Bon alors, bonjour à tous, bienvenue à ce séminaire. Aujourd'hui on accueille Guillaume Anciaux de l'EPFL qui travaille au laboratoire de simulation mécanique des solides avec Jean-François Molinari. Guillaume a fait sa thèse à Bordeaux sur des techniques de couplage de multi-échelle entre dynamique moléculaire et électrochimie. Et après ça, il est parti directement à Lausanne, c'est ça? Ouais. Et même si tu n'as pas beaucoup bougé de Lausanne en termes de thématiques scientifiques, Guillaume il a vraiment parcouru un pays assez large sur le contact, sur la plasticité cristalline, d'autres techniques de couplage, des grandes transformations, quoi d'autre, pas mal de choses.
Des modèles réduits, un peu de robotique, ouais, c'est assez varié.
Donc voilà, tout ça depuis Lausanne. Mais aujourd'hui, Guillaume va nous parler un peu de données scientifiques, de la gestion de données liées à des publications et aussi de la réutilisation des données. Donc Guillaume, je te laisse la place.
Merci beaucoup. Oui, donc je savais pas trop quoi faire. Et puis comme c'est enregistré, on m'a suggéré que c'était possible de faire en anglais, donc je vais switcher en anglais. Mais si vous avez des questions, évidemment, je suis francophone, donc vous pouvez me poser les questions en français sans aucun souci. So today I'd like to talk about open access and open science at large, and in particular for an initiative that I do within the GTCAM, so the Journal of Theoretical, Computational and Applied Mechanics, for datasets in particular. So I would like to speak and to motivate why we do this, and I take this opportunity also to speak a little bit about open science in general. And so I start with this. If we're a researcher in the shoes of a reader, our needs is the following. Okay, so we need seeing the papers that we read to be comprehensive. We need to trust them. We need to be able to find them. Hopefully, we would like to have reproducibility so that we don't spend months on reproducing some results. And we need easy access. Okay. And if you're in the author shoes, so you want to get visible, you want to support your career, you want fair evaluations, and you want some technical support possibly. Okay, and this is slightly different, but what I want to stress here is that in all cases, open access is a plus, right? In both these directions, it's really good, either to make your paper visible, either to make your search and your literature review easier. Okay, and so that's why I just start with an history of academic press. So I'll try to be short and not to take too long because I can speak about this for ages. And this history, I really invite you to read these references. It's taking from this, especially the recent one against parasite publishers. And it's telling the story of how our system is now built. Okay, and so it starts in this year, so 1450s for the printing press, and of course after, you have well, it's advancing fast in the years, but then you have the Journal des Savants, Physical Translation of Royal Society in the 1960. Okay, and so it positioned what we want for scientific journals, which is the task of registration. So we want to associate the authorship so that we can know who is the author of a certain work. We want some peer review, so that's called the certification. We want to be able to disseminate, that's the role of the journals. And we want to have some archive systems so that we can have a permanent link. And this task did not really change so far. It remains the same. It's just the organization and how it's done that is different. Okay. Then way after this, we have this region of time where we specified what is the author and copyright treatment that we have with these things. And for example, it's remarkable, and it's described in this source that initially it was possible to reproduce with no need for asking to the author in principle. And that was the contrary of now, where you in principle, it's forbidden, and you have to ask for the permission to publish. And so this dates from the beginning of the 19th century, of the 20th century, sorry, and at the Rome Act in 1928, we have the author's rights that are being distinguished from the copyright. Okay, so you have people paying for some research or for some piece of text or piece of media that is different from the copyright holder, so the right to make copies. And where it becomes interesting for us is that post-World War II, we had the budget that increased vastly. And this is the graph that I get from an US agency about the R&D money spent in billions. So that's corrected for inflation. So we see that it increases. But on the other hand, if we make it as a percentage of the GDP, we see a rather decrease. Okay, and so I don't know, but I think in general, people are seeing that the budget are shrinking for what is put in research, so it depends. And so that's maybe a problem versus the system of publication management we have. So that's a problem that we see at EPFL, and I'm sure it's visible in other places. Okay, so to continue the history landscape, so we have the creation of Pergamon Press in 1951, and that's from Sir Maxwell, who actually invented the business model so that we have many thematic journals. Okay, and that's at this moment where really we have these specific disciplines, very precise, that are created, and what to say. So that was a model that did not exist before. That's what I can say. And so in the 1970s, the crisis started. Oh, I don't have my mouse. Yeah. In the 1970s, oh, yeah, I can show it here. So in the 1970s, we have the subscriptions for journals that started to rise. And so the crisis began so that we initiated the creation of the XXX long gov and what is to become the archive. And after Pergamon was bought by Elsevier, the prices rised. Okay, so these cartoons are from PhD Comics, obviously, but what is interesting is to see that the rise of the cost for the journals do not follow the inflation at all, and so it's a peculiar way of handling this. So as a reaction, open access will be created. So, but just to recap for the model, what is the problem? Well, if you have these little guys here that represent the flux of money, and so if you think of it, the money goes to the publisher, and we as reviewers do free work. Okay, we do free work. Of course, there is a mission behind these publishers, is to guarantee the task that I was mentioning before. And it has some cost for operating, for archiving, for organizing the reviews. Okay, but still we are the ones doing the work and making the reviews in particular, but also producing the papers. And so the universities in the end also pay for the journal subscriptions. And so that was a problem, especially if the journal subscription rise, which is what happened. Okay, so open access emerged in the 2000, and what to say? Basically, it's a new system that emerged with a system where the publishers said that, well, we should have some article processing charges. So again, I don't have my mouse, and that we need to basically fund this, and so it was followed by the agency, so that we can have funding to pay for these APCs. So it's in 2018 in Switzerland we could claim in our proposals to have some money to pay for these APCs. Okay. The problem is the following: is that it's we don't have any more money because it's open access. Okay. But still, now we have to pay for publishing. Okay, so in principle, as I said, it's okay because we have value and work that is done for this to be organized for the publishing. Okay, but The problem is the problem of cost, as per my understanding. Okay, so here is another paper from Grossman et al., where the estimate which is provided, counting mostly a lot of factors, rise to the cost of $400 per paper. So that's a conservative estimate, and it was evaluated. Probably I don't need to speak about this in detail, but they try to count everything, including the organization of the APC collection, which is a bit, it's necessary somehow, but it's questionable maybe. And they arrive to this conclusion, okay? But the problem is the following, that the APCs are actually the scale with the impact factor. So we have a system where we don't actually pay for what is organized as a work. We pay for something that is closer to the reputation, okay? And I show you this graph. So it's again extracted from the first source I showed at the beginning, and you can see that we have very, very high APCs in some cases. Okay, and this is coming with the revenues for these major editors. So we are talking about $3 billion for the year 2022. And if we compare this to the operating margins, we see that Google and Amazon do not compete with Elsevier and Taylor and Francis, okay, which is also very questionable. So that's why open access model, so I'll just do another quick review. So the gold is the one with APC, so it's when we pay for the publishing mechanism. That's something that we hear more and more now. It's a green, so it's a self-archiving. So you put your preprint to some institutional repository, and then you publish it in a normal way, so possibly with no fees because people will have to pay. But then you count on the fact that you can transmit the copyright and that no problem will happen because your original paper is already published somewhere with no review, but the content is already published in an institutional repository. And what you do not have though is there's no metrics anymore. Okay, so if you count on well, you have metrics if you push it to a normal journal, but the revised version, the reviewed version will be, but the institutional repository container is not indexed in general. Okay, and you have the diamond. So that's why I'm here, and what I want to talk about it's the mechanism for GTCAM. And so diamond open access refers to academic text, sorry, but there is no fees for the reader or the author. So obviously someone is paying, and in that case, for GTCAM, it's the CCSD, so from EpiScience platform, which is co-founded by CNRS in particular, but in other instances. And on top of it, the EpiScience and the GTCAM counts on the overlay journal paradigm, where what is it is just we don't organize actually the storage of the paper itself. The paper is stored in some other institution. In this case, it's HAL most of the time. It could be archive also, but we don't store the paper, and we work on some support that is already here. I will go in more detail on the review for the GTCAM. Okay. Yeah, so that's Swiss recommendation, and you see that diamond open access doesn't appear anywhere. So we have either the gold, either the green, which is I can discuss and debate about it, but there are some problems, and the pay article processing charges. Okay. Okay, GTCAM. So that's the Journal of Theoretical Computational and Applied Mechanics. Here you see the technical board, so the people that are working behind the desk, so that the reviewing, publication, exchanges, is possible. So you have Vladislav Yastrebov, who's here in the room. This is me, François Gibier from Montpellier, Mathias Legrand from McGill University, Maureen Montagna, and Vincent Akari. And so you correct me if I'm wrong, Vlad, but it's an initiative in principle at the beginning from Vincent and Matthias, right? Yes. Yeah. And so I joined, I'm the last one coming because of the data sets in particular, and the others are there from the start of the initiative. Okay, overlay journal. So I talked about it already, Diamond Open Access, that's the description of the journal. What is the team? So internally, I'll go quickly. But we have a technical board that is creator of the journal plus data software editor, which is me. We have a scientific board made of invited people, an editorial board who is elected. And we try to make everything very collegial in the decisions and the directions that the journal take, just for ethical reasons mainly. It's peer-reviewed, and we publish the reviewer's work as open review. So the anonymity is optional. Okay, so you can be anonymous, or you can reveal your identity if you wish. But in any case, we'll publish the review so that the work that is done behind the desk is also bringing more value to the paper itself and the reviewing process. And recently, we've been doing a data and software review curation, so that the goal is to try to do reproducibility for the work. It's still ongoing, as you will see after. I hope yeah. And yeah, copy editing, we will talk about it again. We think we do a particularly good job, and it's very, very time consuming. So just to recap, the publication process is the following. So you have some authors that have a paper. They will publish it to HL or archive so that it's in the form of a preprint. And then it goes to the GTCAM editor with nominating reviewers in a classical way. Some other preprint will be emitted for the revisions that are deemed necessary. Then we produce, after the copy editing, the final version. And we attach to this the review themselves, and also the data sets with the curation, so that we push people to put it on Zenodo. I will explain why that's the only solution. And for software, we push it to be on software heritage. Okay. That's another recap. We have the FAIR principle, so you have the letters, so for findable, accessible, interoperable, and reusable. Reusable, it's about the software heritage. It's maybe an important point. People at the technical board, including me, believe that it's good not to put only your software on GitHub or GitLab, because it's not really fixed, and in the archiving process you can lose things, or it's depending on external people. And with software heritage, we will be able to make a photograph of your Git repository that is permanent, that is associated with the software heritage ID, so that it's permanent. So you have real guarantees that it will sustain time for this. Interoperable, we need repositories with metadata, so that's part of the curation tasks. Accessible, so it's through the EpiScience platform, overlay journal. That's a good thing, right? I mean, when you submit to GTCAM, you have to first put a preprint. That's mandatory. So most people do it anyhow in archive nowadays, even for normal journals. But here, that's the principle. You have to put it somewhere first before it gets reviewed. So anyhow, it will be there. We push for Creative Commons licenses so that it's the most open possible. And findable, so we are part of these networks, but we are not part of the Scopus network or these things, and we probably will not be. Okay, we are having discussion now so that we stick to OpenAlex, for example, and try to push it. But certainly we probably will not be part of these other metrics that are for standard publishers. So that these are numbers for the challenges. maybe one that I can claim is, okay, I acknowledge the work that is done in copy editing, even for normal journals. That's something. And Mathias Legrand and sometimes also Vlad are paying a huge load, and myself also about the data. For having the quality that we want, it takes time and it takes commitment from people. On the other hand, it's good to have people that are skilled with this, that knows mechanics and things. Some parts could be done because it just takes formatting, and some others probably will not be doable by someone that is a general scientist. So we are trying to find money and to make a file. And one of the ideas was to maybe find students that are needing some contracts and money to do these things, so that we get the skills also. So that these are emerging ideas, but I think on the principles they are very good. And I will now talk about the open data very, very shortly, but what we have is that when compared to other disciplines, scientific disciplines, mechanics sometimes face cultural limitations, so they are not very inclined in making their data sets clean and published. So that's not a generality. Some are very, very good at it and very collaborative, but some others are very far from being in the level to do it. And for this, we are, for piloting for this, and that's what I'm talking about also today, we are developing a curation tool, and that's part of a Swiss project that I'm the PI for, where we really dedicate our work to curating the datasets. To finish on GTCAM, GTCAM bets on what? On the ethical principles. So we want to be open, we want to be democratic in a sense for the organization, and we have very strict ethical principle for openness. We bet on the overlay model, so that we don't have so much cost besides the volunteering work that is provided by Mathias and the others, and we also bet for the review and copy editing, but for the data set also. Okay, so we really think we do a great job, even though we don't have, as you see, so many papers published so far. But we really want to make things of good quality, reusable, and for all these standards. Okay. Open data. Okay. So if we talk about data, this graph is extracted from a report, a Swiss report, trying to evaluate all the resources and the possibilities that we have to store data. We have these classical cycles that you can find in other sources, including French ones. Well, we start with the data creation. So the moment where we want to emit it, probably you work on your laptop, or you have some experiment and you acquire the information. Then suddenly you have to store it really on a remote device, so that it's a bit safer, and you start to document it. Okay, so that's where you want to probably use electronic lab notebooks. You want to attach a few features so that it's easier to process. Then the processing and analysis. So if we talk about simulation work, which is my field, really have the data creation, so that the output of your simulation, we store it, we try to annotate, we organize directories where we have our production, and then we want to start to make graphs, to process it, and to try to extract the meat out of it. Okay, and for this, because of the processing, might be doing several trial and error kind of process. We really want to keep all the information as much as possible, so that it's reproducible somehow. After, when this stage is done, we want to do long-term preservation. So we talk about research data archives. So that could be institutional. So I don't know what is the policy in each of the institutes in France, but for example, in Switzerland, at EPFL, they have decided that they will not have a institutional repository that is for everyone, whereas in Zurich, they decided that they would pay for this service. So that means that they have a different strategy, but anyhow, they propose something. So at EPFL, they propose basically Zenodo for things that should be long-term preserved. and it has with some limitations. Then we have the publication, okay? So long-term preservation and publication might look the same, especially if you use Zenodo, but if you have an internal repository, it's not. Okay, if you first publish something at your university, well, it means that you can make it private to your collaborators and not necessarily to the public. Okay, but then there is another stage where you want to publish your paper and possibly want to publish the experimental data or the output of the simulations. And once it's published, what you want is to get the reuse, and so that's also some step that is very important. I'm sure you have faced so many times this situation where you try to reuse the work from someone else, and it's not so easy, okay? Because one of these steps before in the organization was not maybe so well made, and so it's, or maybe a context is not saved, so you have actually the version, but it's outdated, or it was private software that was used, and then you lose some time to re-implement, to recode, and these things, okay? But somehow in the process of data, ideally there would be someone else reusing the data. Otherwise, why would you store it in the first place? Probably you don't want to store it, okay? And the reuse might lead to a new data creation that is a cycle that is virtuous in principle to foster scientific discovery. So I'll probably put my slides somewhere. I have put many links here and there, and this is a resource for people interested that is in French. It's a set of cartoons. It's called On fait le point sur les données. It's very nice and interesting for the educative purpose and for becoming sensitive to these things. Okay. Findable, accessible, interoperable, and reusable. So what is necessary mainly is digital object identifier, so something like a DOI for your datasets. Accessible, you have the question of retention times. I will have my final slide talking about, when exactly do we think it's worth it to store a big dataset? And that's not so clear, but we have to, if it's big, and if we talk about Zenodo, for example, Zenodo is financed through the CERN for 20 more years from now, but after it's not clear what's going to happen. So if there is a question about this, and I know archivists at the EPFL that are storing data for more medicine things, and they do a constant curation. So they have a retention time that is extremely long on purpose, or if you talk about astronomers, medicine or these things, experimental work in general, you want to keep it as much as possible because it's very expensive to produce. And in such a case, the retention time should be large. But maybe for a simulation work on finite element, you could decide for something shorter, and after a while, maybe decide to store only a limited amount. Okay, that's something that needs to be decided. Then you have to decide where to put it, and that's basically the jungle. If you search a little bit where you should put your data, well, you have the generalist ones, the Zenodo, which is well organized and everything, that has limitation, but you have a lot of these things here and there. Interoperable, that's also a mess because of the variation. Every system is having a different technology, so it's not so clear that you can quickly interoperate and reuse. And finally, the reusable, so you need basically the context. So here I summarize it, the software versions is a minimum, the dependencies, and if it's not open source, how do you do that? So that's not so clear. Okay. But here for curation, the most important is probably about annotation. Okay, so here in this cartoon, you see, je n'arrive plus à retrouver dans les données du laboratoire coccinelle. Pour décrire les études sur les voitures, ils ont utilisé les mots automobile, véhicule, bagnole et char. So there is this notion. So it's a bit exaggerated probably, but there is this notion of vocabulary. What do you use to characterize your objects? And the fact that if you have communities that are somehow similar, not so far away in terms of theories, but they use a different vocabulary, well, they cannot talk to each other. So how can they share the data sets? That's also some problem. So we need annotation and cleaning and some sort of normalization. If we look at journals policies, so I just took this example with a Springer, so that's something that is published. These two things are links. This is the official policy, and here is where I can find this publication where they describe the classification of journals in terms of data. And personally, and for GTCAM, I'm interested on the type 4 only, so data sharing, evidence of data sharing, and peer review and data required is what we aim for. We want to have all this. We want to review it and to have a reproducibility and access. And for this, so we have computational mechanics, but also mechanics should be of type 4. That's what I believe. And Springer journals, what they did, they created journals for this. Okay, so this scientific data, BMC series, and Discover are journals specialized for the datasets. So seemingly they are reviewed, but they created new journals for this, okay? And if you talk about the JOSS, the Journal of Open Source Software, the process is very mature, and you have a review process for the software that is pretty good. And now you have, I think, GTCAM, which is quite uncommon with this ambitious goal. And I would summarize it this way. To me, it makes sense to have the review of the paper that is close to the review of the data sets. Because if we split it, like in this case, but even this case, because we publish the software itself but not the results, it's good, but on the other hand, you always have the situation as a reviewer where you have a piece of text, very well written, nice results, but you cannot realize like this whether it's reproducible or no. And if you review the data sets, well, you probably don't have much of a sense whether it's sound scientifically either. And ideally, if you would have time for all these things, you as a researcher would be a reviewer, and you would also review the data set, and you would check that it makes sense. Okay, and there is this question of how much time are we ready to invest in these approaches. Okay. Here, what you can see is the official dataset curation policy for GTCAM. Okay, so it's a bunch of items that are easy to tick. I would say must be open. Ownership described in depth. So just the authorship, right? You would like to say in all the files that are produced in the dataset who created and who made a contribution to produce it. Detailed description, okay, you want to have not cars and manual at the same time to specify for the same thing, so it will call for control vocabulary. You want cross-link references. The first thing that we do is we create a link from the dataset to the paper for the GTCAM, because it's important. We have the software permanent links. We want to acknowledge grants. It needs to be clean. A huge part of my task as a data editor for GTCAM is to look at the files and to say, okay, this file is not necessary. Maybe you just can remove it, and it leads to this kind of adaptations. Or maybe you should rename it or complete the documentation. We want to have as permissive as possible licenses. That's also a wish, and sometimes it's complicated to enforce, but we would like to have files formats that are open, okay? Because if it's closed, it's not clear that the routine that is used to read the data will pertain in time, and that we will keep being able to use the data. And also something quite difficult is the workflow description. We would like to be able to reproduce the data, so we need to know exactly what is the sequence of commands and tasks that has been done to produce the data. Okay? Okay. So let's talk about curation a little bit. Okay, so the data storage and the curation is different. Data storage is simply to store the data. Data publication is to give the research data and metadata reproducible and findable. I said this already. The archiving is to maintain the physical integrity of the data and the access through time. So that's really an archiving kind of process. So that an example I give sometimes is if you have a file format that 50 years ago was the main format, well, and nowadays it's not anymore. Some data archivists should actually change the format and maybe proceed to some conversion. And the data curation is it's a bit through all this, so it's a validation of the data. So the encoding of the file format is correct. The description is complete. It's discipline dependent. Nature is well respected, okay? So, and usually the curation is done or should be done by journals, universities, and specialized archivists. Like in astronomy, I work recently with astronomers, and they have a different culture and different way of doing this, but you can imagine that when you take a picture from the sky, there's no other experiment you can do to have another image. So you have to have strict rules and curation so that it's exploitable by models. Okay, and so I believe it's a central pillar for this. Okay, if we to do the easy way, and something that you probably should be familiar with, is if we want to have a publishing and curation for software. Well, we have major development tools. So we have the Git, which is used by mostly everyone now. And we have the developer platforms that allows to have discussions, to make reviews, to make propositions, through the merge request, and so these things. So it's pretty mature. On the other hand, we have to be careful because it's also very volatile. So you have to use permanent IDs, but this I said already. What's maybe less present in the dataset that I see is a question about reproducibility and regression tests. You have to understand that if I am having the task to guarantee that I can reproduce your results, if you just give me the code, I can read the code and see whether it's well written, it's documented enough, but I cannot really reproduce it. So a good habit would be to have this test and these sequences provided already. And if you're in the development part of this thing, so if you're a developer for some code, it's natural to have these regression tests. So you code a bunch of tests that are sent automatically. Okay. The only problem is that for a given code, they need to be conceived by authors. I cannot ask this to anyone else but the ones that are actually making the simulation software or the post-treatment software or whatever it is. Okay. From the point of view of GTCam, again, if it's not open source, it's not going to lead to any perennity because I'm not going to be able in the future possibly to use the software. And even that, I mean, if I need to pay for a license to be able to review your results, that's going to be a problem. And even if I as a data editor, I accept to pay the license, what do? Should I convert the data or should I put it in the data set and leave it like this? And then it's not open to the rest of the world. If you think about, from rich countries' point of view, sometimes you can pay for these things, but it's also good, these open strategies for countries that do not have the money to pay these licenses and to have access to this. So I'm really insisting on this. Also, a community that is pushing a lot is a machine learning community because they have all this system of pipelines where they would like to have a list of data sets that they could just inject in their learning pipelines. And the best automated it is, the more efficient they will become and will treat for this matter. Okay, and at the moment, I hear discussion here and there for also other journals, other communities. They have to pay a lot of work to extract the juice to be able to feed it to training strategies. So that's something that we probably should work on. But we can benefit from their experience in terms of this, for the code at least, and possibly for the data sets. If we speak about the datasets themselves, so I said I would provide a few numbers for Zenodo. Just the long-term preservation offered by Zenodo is for 20 more years. So this is a link where the official policy of Zenodo is provided. After, it depends on the states whether they will commit again the money to CERN. If they do, we will have more years to our storage. But as long as these 20 years, the guarantees that every dataset that is entered in Zenodo will not be removed. But it's generalist, so they store anything. There's no check, there's no moderation, which is possibly a problem. You probably can find some tests with empty datasets from people, and they cannot really remove it. Or you, just like in HL, you actually can make a request, and they would remove it to be publicly viewed, but they will still be in the database. Okay, but the guarantee that after it's published, it's read-only and you cannot change it. You have a 50 gigabyte limit, so that turns out to be a problem for some experimental datasets where you can actually be much larger than this. And that's where curation should play a role here, right? Because if you have this limit, which it's not nothing, 50 gigs, and if you're way above this, maybe you should work a little bit your dataset so that it's usable for the people. Or you have to find another place than Zenodo, but you will be the warrant for the retention of the data. On the other hand, the metadata is always modifiable, and that makes sense because every new paper, every new dataset that is coming with this, you create new links and new information, and that's good because, for example, we have this mechanism with communities. So here you have a link for the GTCam Zenodo community. And what we can do is that if a dataset is published in this community, we can act on the metadata of it to create these important links of archiving. Okay. What content would checks? No one but the owner. And we have a project, so I saw it yesterday while searching for it. They plan within this project to introduce some curation procedures for validating the datasets. It's ongoing, so that's to follow. But well, I spoke a lot and I said a lot of things, and I think the major criticism I see is that okay, this is work. this is work. Why should I give this to the first one? So my answer would be, yeah, to be open for a good principle, to foster exchanges in science so that you're visible. Remember, one of the first things I said is that if you want your career to advance, possibly you want to get visible. So it's not, everything is published, everything is given, so it's always good to publish it openly. But if you publish something that is not well organized, it has less value, and then it delivers less merit to the people reading it. Okay? And here in this, again, that's what I think, and that's why I'm here in GTCam, is that I think journals should play a role. They organize the review of the papers. I think we should organize the review of the data sets. Okay? And so that's now the part where I'm really into the curation, so that the project I'm working on that was funded by Swiss Confederation, and it's an online service where we have the datasets that can be provided. And so here is a summary. We have a cloud-based repository. So that means that a bit like Git, you do git clone and you get a copy of your things. You can do the same with datasets, and if the dataset is important, you don't have to copy it. Okay, you can work remotely. It simplifies the verification, analysis, and annotation, and it is used for reviews at the GTCam. So what does it do? Concretely, the software, and that's going to be important a bit after. We first start by looking at the remote repository for the storage, and we do we make the access possible. So that's a mounting in terms of a unique operating system. And once this is done, then we can look at the files remotely. So that means within my laptop, and in principle, I can look at a 50 gigabyte data set, and I just will claim on demand what I need to look at. Then the Solid EPS curation tool will scan files, and for every file, it will do the following. It will identify the encoding and the file format. Then it will extract the metadata. So here I give a few examples because I have a lot. I extract the CSV headers so that as a reviewer I can check that I have the proper name, units, these kind of things. Okay. In terms of properties, we want to extract the number of pixels, and if we are talking about photography, the shutter speed we would like to extract maybe. And for finite element, we would like to have the field descriptions, what they contain, the size of the tensors that we want, these kind of things. Why is that? It's because later it will be represented, so that as a reviewer, I would like to know what is contained by my file the quickest possible, because I don't want to spend time opening any software or fighting with downloading the licensing and everything. That should be at least partially automatic. Okay, then we will do an attempt to load the file. Okay, it could be partial loading, could be just the header, for example, for CSV, so that I get a control. And if some other test is provided, I will do some validation checks that will highlight whether a file is valid, yes or no. Okay, and after this is done automatically, I can generate a report, either in text mode for the terminal, either in the form of a Jupyter notebook, or with a web app that is graphically showing me what is contained in the dataset, with a report for what is good, what is not good. And that we worked especially, so the title of this project it was for Solid Mechanics, so we worked in being able to do 3D rendering of meshes inside of the web browser. So that's something that we worked on so that it's made possible. And if it's all good, then we can export to Zenodo or to Renku, which is another platform, and I will talk about it a bit after. Ooh, I'm super late. Okay. I'll. Okay, I can just show the platform how it looks like. Okay, so here is the platform that you see. So we give the opportunity to edit a bunch of metadata, which are all important. So you have the license, DOI. All the links, some are extracted automatically. This is a dataset that was made by Elied and Rehan Seguir and Julien Rétoré for the GTCAM. And they provided a description that is quite comprehensive. And also some files, so I just prepared it so that I get quicker. But you can see these kind of things in the browser. You can play a little bit and you have a summary of the fields that are stored. And basically, it's just a click button kind of effort so that you don't have to fight too much with it. And that, in most of the cases, should be what you have. And this platform, so here I launched it locally on my machine, but on this other here, it's online. So that's the Renku platform. So we embed with this data set all the context to reproduce this platform and also to relaunch some of the calculations. Okay. So the principle for the dataset curation is the following. So we have some kind of review process that is done in using the web platform that is available, so that we can process to some modifications, annotations, we can do the data reviews, send them to the author, and we loop like this. And once we are done, when everyone is happy, we can publish it to Renku or to Zenodo. Okay, what is missing? What is the ideal curation procedure? So what's missing is distinct disciplines. I'm facing a situation where we have very specific needs depending on this subfield. And that's why I associated recently with astronomers to get to something completely different, to see how our platform can adapt to new situations and to get contribution from the community. Okay. Concurrent editing, it's something that is provided by the web, but it's still something where we work. We need robust description and normalization, which I call ontologies. I'm not sure I will have time to speak about it today, but that's to find proper names for all the objects that we manipulate. Workflows, that's pretty difficult. Why is that? It's because when you work on your simulations or on your post-treatment of your experiment, well, you have a lot of trial and error. And once you have spent a year working on it, maybe it's too late to package it nicely and have it. And we are trying to use some projects that is capable of gathering the environment on your machine, to collect the operating system versions, to collect the packages that are installed, to collect the versions, and to package it so that we can exploit it and send it with the datasets. So that's something that we are going after. And also large datasets and CO2 emissions. So that's something that I would like to assess, because if I ask you what is the question, when should I keep a dataset or when should I just keep the input? It involves a lot of energy consumption, a lot of CO2 production that is from people I've been discussing with. It's not so obvious. So I should finish, right? Yeah. So I'll just go to the conclusion. So where we are, we have a tool that is providing loaders and viewers, mostly for continuum mechanics, but really we are really conceiving a system of plugins so that you could, in principle, make a small project, a tiny one, where you provide your loaders and your viewers, and they will be usable within the curation tool. And that's how I think we should organize the contribution of the community so that we extend the possibility of curation. Okay? We are now flexible in terms of data storage because we can use, through the Renko interface, we can use several mounting points. And we have the curation policy that is set for GTCAN. We have a user documentation that you can have a look if you are interested. What is the next step is really the characterization of the vocabulary employed to describe the objects. And the total workflow, it's mainly a manual task. So we are working on this, but we hope it will be better soon. We want to have a better advice on whether we should keep the datasets, yes or no. And we want the plugin to be multidisciplinary, but I said this already. Okay, sorry for being a bit late. I could not say everything, but... Okay, cool.
Est-ce qu'il y a des questions?
J'en ai une qui n'est pas au cœur de l'exposé, donc c'est sur la première partie où on publie les reviews. Je me demandais quel était l'objectif et pour les papiers qui sont enregistrés, on en fait quoi?
What is the I think it's we believe that there is value in the discussions and what is the path that was taken for the paper to be in its final form. And sometimes these discussions are very rich. I'm sure you have participated in a discussion for your own papers and the reviews. And really, the value that is provided by reviewers is probably better acknowledged like this. So if it's anonymous, I'm unsure, but the process in itself has value to our eyes. And what do we do if it's not accepted? I think we don't publish. So there's no wrong incentive into making a negative review, right? So we don't. In that case, we will not publish it, so that you should not be feeling at risk to make a negative review. Yeah.
Non, mais je les ai lus, c'est intuitif.
Yeah.
Mais je me demandais quand il y avait une opposition très forte entre le review et le point de vue de l'auteur et vous devez trancher comment ça se passe. Bon, j'ai compris.
Ok. Vas-y, complète. Hein.
Je peux rajouter juste une phrase. S'il y avait un moment de review opposé, c'est soit le troisième réviseur qui entre en jeu, ou bien c'est l'éditeur qui doit justifier sa solution, sa décision, et à la fin, c'est l'éditeur qui prend le aide, qui aussi écrit la conclusion dans Open Review, et fait aussi partie de l'éditeur qui justifie.
C'est intéressant de savoir que l'éditeur joue un rôle
Tout à fait.
et qu'il peut vraiment prendre des responsabilités si c'est nécessaire. Merci.
Oui, merci. Merci beaucoup pour la présentation, c'était passionnant. Moi, j'ai beaucoup de questions, mais peut-être un commentaire. C'est est-ce que tu ne penses pas qu'il y a un décalage assez grand entre les pratiques actuelles des chercheurs et ce que tu proposes? C'est-à-dire, ce que tu proposes, c'est très complet, ça paraît très ambitieux. Ça me paraît peut-être un petit peu idéaliste d'imaginer que les chercheurs vont passer de ce qu'ils font maintenant à ça d'un coup. Est-ce qu'il y a des étapes plus simples qui pourraient être envisagées pour leur faire passer le pas? Parce que là, on parle de choses qui sont très techniques, centralisées, avec des procédures, et c'est pas forcément très facile à vendre aux chercheurs pour les faire avancer.
I completely understand the question, and the way we process with GTCam, I think, is the right one. So we are not forcing anything, and my editorial service is actually an help to researchers. I'm helping them to get to this standard, and that makes me work a lot with them, exchanging a lot of emails in these cases. What I believe is that the more datasets of this kind, well formatted, we produce, the more they will become reused, and the more it will become a habit and a norm. But we will not enforce the norm directly. First, because GTCam is still a new journal, and if we add more constraints, we probably get even less submissions, and we don't want that. You don't seem to agree, Vlad. I think that's we have both an educational strategy, and we are really willing to help people to get through this. So the difficulty now is that if you have done 4 years or 3 years of PhD, you have not worked at all with these practices, it might be an overwhelming effort to package your dataset at the end. But then this curation and this policy for curation that we have is not a strict line. We adapt, and what we want is to highlight the procedure and to highlight the good practices, I would say. It's okay?
Juste un commentaire peut-être, tu as mentionné que c'était difficile de convaincre les chercheurs de le faire parce qu'ils voient ça comme je donne des choses en fournissant plus de travail. Tu as mentionné le fait que la visibilité de leur travail qui compte pour eux, c'était un point important, ça leur apporte. Donc il y a un point très important aussi, c'est que les premiers bénéficiaires de pouvoir reproduire son propre travail, c'est les chercheurs. Il y a le nombre de chercheurs qui n'arrivent pas à reproduire leur propre résultat 2 mois après les avoir obtenus, c'est énorme. Et donc le premier bénéficiaire de ça, de prendre des bonnes pratiques, de documenter, d'avoir des choses reproductibles, c'est les chercheurs qui sont frustrés parce qu'ils reprennent leur papier 1 an après, ils veulent améliorer leur résultat parce qu'il y a une nouvelle idée, ils n'y arrivent pas. Donc en fait, je pense qu'il faut mentionner que les premiers bénéficiaires, c'est vraiment les chercheurs.
Et je suis entièrement d'accord. Et puis je pense que quand on est prof et qu'on a plusieurs PhD students qui sont en train de produire des choses séparées, on a avoir un outil qui permet de le mettre sous une interforme et de pouvoir le regarder rapidement et de savoir qu'il est packagé de cette manière-là, c'est peut-être quelque chose qui est aussi très rassurant et qui garantit certaines choses. Ça peut aussi, pour le passage au prochain PhD student qui vient pour un projet qui continue celui-là, c'est moins d'efforts pour tout le monde. Donc après, je suis très convaincu que ça sert aussi les chercheurs eux-mêmes. Et de manière générale, je pense qu'on est des gens qui ont un lien très fort aux mathématiques. Je pense qu'on aime bien les choses un peu carrées quand même, sur le principe. Du coup, ça fait plus plaisir de produire quelque chose qui est un peu propre que quelque chose qui, de fait, s'est installé comme quelque chose d'un petit peu... le bazar, je dirais. Ouais. Oui.
justement, pour répondre sur le commentaire de Stéphane, rebondir. Est-ce que ça vaudrait pas le coup d'enseigner ça directement à la fac à des étudiants et des étudiantes, et si oui, finalement à quel niveau? Parce que ce genre de pratique est aussi très bien vu dans l'industrie, le fait d'avoir des données reproductibles. Donc ce serait finalement aussi gagnant-gagnant pour tout le monde. Est-ce que ça vaudrait le coup de se baser justement sur cette plateforme qui existe pour montrer un peu, un peu guérir le problème à la source en quelque sorte?
I really think education is a key. So we are starting to, with the library of EPFL, to try to have classes that will teach both the articulation for the publication paradigm, also the publication system, and also for the curation at the doctoral level. So that's what we want to do. So ideally, what I would like is to have fresh PhD students arriving, to have a 1 week crash course on these things, so that at least they know that these things exist. They have a little hand-on on manipulating these tools, could be Git, this software, and so that they know what is the norm, what is the standard, so that they are not polluted later by discussions where it's okay to do it the way you do. I mean, they know what is the goal to achieve, what is a normalization. Whether they do it or no, it will depend on the precise work of the PhD, but they know that the goal is this. And we plan to do it at the early place during the PhD career, but it could be done before. But that's what we're trying to do now at EPFL. Okay, but I'm happy to, if someone is willing to teach this before and you have place in your curriculums, I would be delighted, but I think the problem is also to find a slot for this in the curriculum.
D'autres questions?
Thank you very much for the presentation, very interesting. I will switch in French because parce que en fait, je vais parler d'un problème français qui est que c'est qu'il y a des injonctions étatiques qui font qu'il ne faut pas publier les choses en l'état. Il ne faut pas que les gens puissent recopier ce qu'on fait et qu'il faut un peu cacher toutes les belles productions scientifiques que l'on fait pour éviter qu'elles ne tombent dans de mauvaises mains. Donc ça s'appelle la protection scientifique, la PPST ça s'appelle. Donc il y a des enjeux politiques, il y a plein d'enjeux. Quel est ton point de vue là-dessus?
Je vais faire en français du coup. Mon point de vue, c'est que verrouiller l'accès à l'information est un frein pour la progression scientifique, c'est quelque chose d'absolu. Après, je comprends très bien, j'ai aussi des projets avec des industriels où il y a certaines choses qui sont sujets à des patents, certaines choses qui doivent être gardées secrètes. Et dans ces cas-là, alors soit c'est pour une période de temps, par exemple pour la soumission de patents, et à ce moment-là, si on parle de datasets, il y a la possibilité de mettre des périodes de, comment on appelle, des périodes d'embargo. C'est possible de les mettre en place, et comme ça on peut procéder à la review, à la curation. Même si l'information est protégée pendant un certain temps, ça n'empêche pas d'être cleané un petit peu. Et si vraiment ça doit être protégé pour des enjeux plus importants, la curation peut aussi procéder à une sélection. C'est-à-dire qu'on peut toujours choisir de montrer certaines choses. D'autre part, on fait ça pour les papiers, à vrai dire. On choisit de montrer certaines figures, on retire certains vocabulaires, certaines précisions sur les matériaux, parce que l'industriel n'est pas enchanté qu'on révèle certains secrets industriels, mais on va quand même essayer de publier les résultats quand on a l'interaction avec la recherche. Est-ce qu'on peut pas faire quelque chose de similaire avec les datasets? Si on devait le faire, ça serait en tout cas avec la curation. Donc je sais pas, t'as pas l'air convaincu.
On est productif aussi là.
Alors ça dépend. Si on prend un modèle qui traite d'un matériau particulier et qui fait certaines choses, il peut être employable dans un autre contexte, une autre application, et sans révéler de secret sur l'application, peut être avoir de la valeur. Et à ce moment-là, ce qu'on garantirait, c'est la reproducibilité de ce sous-système. Mais quand on fait un papier où on enlève les constantes, en fait finalement on a résumé le problème à autre chose, parce qu'on veut montrer juste la valeur du travail peut-être théorique, mais pas l'application directe. Est-ce qu'on peut pas faire cette séparation aussi pour les datasets ? Ça serait ma meilleure réponse à ta question.
Du coup, dans cette perspective, je me demandais, dans ce que tu nous as présenté, Guillaume, on sent un peu le côté plutôt Computational Mechanics qui est derrière, mais je m'interrogeais sur les aspects expérimentaux. En particulier, est-ce que dans votre réflexion, vous mettez sur le même plan les questions de reproductibilité, si je suis dans le domaine du calcul scientifique ou de la mécanique expérimentale?
Alors, quand c'est de l'expérimental, il n'y a pas vraiment de question de reproducibilité, on veut stocker les résultats, et ce qu'on doit juste garantir, c'est que les formats qui sont utilisés pour le stockage restent pérennes sur la période de rétention qu'on a choisie. L'exemple que j'ai montré de curation, c'est avec le travail de Julien Rétoré, c'est un travail purement expérimental. Et donc c'était très important que ces données expérimentales puissent être formatées d'une certaine manière. Et c'est ce que je disais à Luca tout à l'heure. On a fait bien notre travail, de telle sorte qu'en fait, quelqu'un qui veut faire une simulation élément fini sur ce dataset et ça lui prendra quelques minutes. Ce qui est pas négligeable. Mais du coup, il n'y a pas vraiment de notion de reproducibilité, à part le fait qu'on doit garantir que les formats de fichiers pour le stockage des données puissent être réutilisables sur le long. Donc ça se résume à quelque chose d'un peu plus réduit, je dirais.
Merci. Bon, on peut terminer ici. Merci Guillaume.